So, how do you actually complete a relative criticality analysis? Start with your list of systems that provide 100% coverage of the assets you're responsible for. Organize a workshop of people that includes, at a minimum, a representative from operations, maintenance, and management of your project. Each will have a different perspective, which is vital to the process. The first step of the process is to identify the worst-case failure scenarios for each system. This will require identification of what that system function is, and then how it can fail to provide that function. These can actually be pretty generic and high level. Usually there are at least 2 ways that a system can fail, at a minimum, and you should probably try to limit the maximum of 4 or 5 failure scenarios, focusing in on the ones that are actually possible. In other words, don't list a meteor strike as a failure scenario. Next, rank each failure scenario against an agreed upon standard scale that quantifies the consequence and likelihood. It's easiest if the consequences are broken down into key areas of concern. To develop a good list of areas of concern, it would be good to review the concerns identified in your level of service. For Gresham, this broke down into concerns for safe work environment, plant capacity, environmental regulations, operating costs, and other concerns for the neighbors, customers, employees, which we called stakeholders, and finally the potential collateral damage to other systems resulting from failure. If you're conducting a relative criticality analysis for a park or streets, you can see that the consequences listed would break down into some different areas of concern. The consequence categories should also be ranked on how undesirable the consequence might be. For Gresham, we used a ranking from unacceptable down to minor. Here's an example of Gresham's ranking criteria for safety. Notice that the scale does not include ranking based on dollars or loss of life. The real focus is identifying a range of risk from extremely likely that the failure consequence will impact a category, which is unacceptable, to only a slight risk of the failure impacting the category, which is minor. Using these definitions of range of risk, it seemed easy for the analysis workshop group to understand, and it avoids the arguments that come up when trying to put dollars or some other measure of consequence to a failure category. As you remember, the relative criticality ranking, like a classic risk matrix, is a ranking of the consequence versus the likelihood of failure. This is a sample of the standard used to rank the likelihood of failure for the Gresham analysis. For us, it was easier to relate to these when we added to the definitions that a common failure is something that even the newest guy can remember happening, and a rare failure or event is something that only the oldest guy or gal can remember happening. Here is an example of a failure scenario where a pumping system stops pumping, its most basic function, and what happens when that occurs. The screenshot on the right is the tool that we used, which is a basic Microsoft Access tool. But it could very easily be developed in something similar in Microsoft Excel, or even a set of paper forms that could be sorted by hand once the ranking is completed. This is another screenshot from the Microsoft Access tool used at Gresham. The criticality code structure is from left to right the number of unacceptables with a colon dividing, the number of majors with a colon dividing, the number of undesirables with a colon dividing, and finally the number of minors. There's a colon dividing that, and then an alpha character, and the alpha character is an indication of the probability of occurrence. The tool does a basic descending value sort. We further rank the systems using the primary code column. Here's an example of a classic risk matrix, which plots consequence versus the probability of occurrence. Another tool that Gresham finds helpful is a table that plots the Computerized Maintenance Management System, or CMMS, work orders by the criticality ranking of the system versus the unit process code. Notice how quickly the maintenance manager can now evaluate his outstanding backlog of work orders and prioritize which ones to do first. If I were him, I would want to immediately know what the work orders were in the red column and plan to have my staff attend to them as soon as possible.